In the vast emptiness of space, two small spacecraft continue their incredible journey, long after they were expected to fall silent. These are NASA's Voyager 1 and Voyager 2, launched nearly 5 decades ago and still pushing the boundaries of exploration. They are the most distant human-made objects from Earth, traveling through the uncharted frontier of interstellar space. And now, in 2025, the story of the Voyagers has taken another remarkable turn. Despite their age and distance, engineers have managed to keep them alive. In May 2025, NASA successfully revived backup roll thrusters on Voyager 1. These thrusters had not been used since 2004, yet after 21 years of silence, they came back to life, firing pulses that helped the spacecraft adjust its orientation. This extraordinary engineering feat was necessary because the primary thrusters, which keep Voyager's antenna pointed at Earth, were showing signs of wear. By reactivating the backups, NASA ensured that communication with Earth would continue, despite the fact that it takes more than 22 hours for a single radio signal to travel from Earth to Voyager 1 and another 22 hours to come back. But keeping the Voyagers alive comes at a cost. On February 25, 2025, NASA shut down Voyager 1's cosmic ray subsystem to save energy. This instrument had been operating for decades, measuring high-energy particles from outside the solar system. Similarly, Voyager 2's low-energy charged particles instrument is scheduled to be turned off in March 2025. The reason? Power. Both spacecraft rely on nuclear batteries called RTGs, radioisotope thermoelectric generators, that slowly produce less electricity as the plutonium fuel decays. After 48 years in space, engineers are carefully deciding which instruments can remain on and which must be sacrificed. Still, even with fewer tools active, each Voyager continues to carry 3 working science instruments. These include plasma wave detectors and magnetometers, which allow scientists to study the invisible boundaries of our solar system and the nature of interstellar space itself. Every bit of data, though limited, is still groundbreaking. Voyager 1 is currently about 165 astronomical units from Earth. That's more than 24 billion kilometers away. To put that in perspective, if Earth were the size of a marble, Voyager 1 would already be over 4 kilometers away. Voyager 1 crossed the heliopause, the boundary where the Sun's solar wind meets the interstellar medium, in 2012. Becoming the first spacecraft in history to enter interstellar space. Voyager 2 followed in 2018, taking a different path. These crossings revealed that the heliosphere, the bubble around our solar system, provides significant protection from cosmic radiation. The Voyagers showed us that this shield blocks about 2/3 of the cosmic rays that would otherwise bombard Earth and the planets. The current mission, known as the Voyager Interstellar Mission, is focused on pushing deeper into interstellar space and continuing to measure this transition zone. What makes this so incredible is that these spacecraft were never designed for this journey. Originally, their goal was to study Jupiter and Saturn. Voyager 2 went even further, becoming the only spacecraft to visit Uranus in 1986 and Neptune in 1989. The discoveries from these flybys were astonishing. Active volcanoes on Jupiter's moon Io, strange weather patterns on Saturn, and the first close look at Neptune's great dark spot. After these encounters, the Voyagers just kept going, repurposed for exploration far beyond the planet. But keeping them alive is a constant struggle. Their data rates are painfully slow compared to modern technology, just a fraction of the speed of your home internet. Their hardware is older than most of the engineers working on them today, and every command must be carefully crafted because a mistake could mean the loss of contact forever. The spacecraft are also so far away that if something goes wrong, it takes nearly 2 days to send a command and receive confirmation. Despite these challenges, NASA's team has managed to keep the Voyagers operational, a testament to ingenuity and determination. The thrusters, for example, are a perfect illustration of this. Imagine asking a 50-year-old car engine that hasn't been used in decades to start up again, and it works. That's essentially what happened with Voyager's backup thrusters. They weren't designed to last this long, and their long-term reliability is uncertain. Yet they are keeping Voyager's antenna pointed at Earth, allowing humanity to hear whispers from the edge of the sun's influence. The Voyagers are also carrying something that makes them more than just machines. Each spacecraft holds a golden record, a time capsule of sounds, images, and messages from Earth, created to represent the diversity of life and culture on our planet. It includes greetings in 55 languages, music from across the world, natural sounds like birdsong and thunder, and even diagrams showing the location of Earth in the galaxy. Carl Sagan, who helped design the record, called it a message in a bottle cast into the cosmic ocean. Someday, billions of years from now, these records may be the only trace of humanity, drifting endlessly among the stars. Looking ahead, NASA expects the Voyagers to remain operational in some form until around 2026. After that, as more instruments shut down, the mission will enter its final phase. Some estimates suggest communication could be possible until about 2036, depending on power levels. Even after the spacecraft falls silent, they will continue to drift through the galaxy, silent ambassadors of Earth. Their legacy is profound. The Voyagers gave us our first real perspective of the solar system as a family of worlds, captured in the legendary Solar System Family Portrait, taken in 1990. In that portrait, Earth appears as a tiny speck, famously described by Carl Sagan as the pale blue dot. He reminded us that on that small dot lies every human life, every joy and sorrow, every civilization, every moment of history. From the Voyager's vantage point, Earth is fragile, tiny, and precious. That image continues to inspire generations to cherish our planet and to seek our place in the wider universe. Today, Voyager 1 and 2 are still sending data, still surprising us, still proving that even the simplest instruments, when placed at the right frontier, can change the way we see the cosmos. Nearly half a century since launch, they remain humanity's farthest eyes into the void, and their story is not yet over.